really glad to be here today. My name is Andrew, and this is my coworker DC Posch, and we are from the Dymo team. Over the past few days, there has been a lot of talk around the fragmentation of Ethereum and how all the L2s are separate and creates a bad user experience for trying to interop between these L2s. The past few months, we've been working on something new at Dymo that we're excited to show you today. This is a step forward towards unifying Ethereum using technology that already exists today while maintaining the core values of permissionlessness and trustlessness. And let's get started with DC introducing the problem of fragmentation and what it looks like today.
Sounds great. Hey, everyone. Yes, I didn't forget about this, by the way. They scheduled us back to back, so I just got off of a panel on the next stage over. Came straight here. Glad to see you all. Let's talk about this. So we're going to, let's see. Do you have the clicker?
Yeah.
Perfect. Thank you. So the problem we're going to talk about today is one that I think many of you are going to be very familiar with. How many of you here have used Polymarket? How many of you here have ever seen a screen that says something like, only send this token on this chain, other funds might be lost? All right, more than half for sure. And this is a very common UX right now. So it's like, select Polygon as the network, not Polygon ZK EVM, or you may lose funds. And it's also a problem that you've probably heard a lot at Devcon, where it's like a lot of the talks here are like about roll-up fragmentation and about chain abstraction and about things like that. And I think the aspect of what we're about to show you that we're really excited about is that we're going to only talk about things today that work today. So I think there's a lot of interesting sort of forward-looking things that people are talking about around things like chain-specific addresses, around things like wallets that have bridging built into them. But we're going to talk about things that work right now with wallets, sort of on any chain, and even with custodial apps like Coinbase, like Binance, like Lemon. Yeah, what we're shooting for is something like, this is from one of Vitalik's recent pieces, this idea of one Ethereum, something that feels like a cohesive ecosystem. And what we're shooting for is something that feels as easy to use, as smooth as something like Apple Pay. So you have like one action, you click send, and it does whatever you wanted it to do. Yeah, I'm going to talk very briefly about sort of the background of like Create2, about cross-chain accounts, about sort of the ideas that inspired this. And then we're going to talk about intent addresses, which is the new thing we're presenting today. How many people here have heard of or like know what Create2 is? Oh, hey, wow, that is, okay, very technical audience. That's great, perfect. Yeah, so it lets us commit to a contract. We can make an address that only one specific contract with specific functionality can exist at that address. The sort of original main use case for this, what a lot of it has been so far, is these cross-chain accounts. So we should do the next slide with the diagram on it. Yeah, perfect. So this is this idea of like, okay, EOAs work everywhere. You have things that only work on certain chains. So for example, like if you heard of the Wintermute hack 2 years ago, where they had a Gnosis safe that hadn't yet been deployed on a different chain, and then someone sent funds to it. It was a sad time. With this, with like cross-chain accounts, universal accounts, you can use Create2 and 4337 to make an account that just works on every chain. And even like new EVM chains that don't exist yet, that one specific contract will be deployable there. There's a whole nice design space around that. And we thought, what if we could go one level deeper? What if we could make this more general? And so what an intent address is, let's do, yes, perfect. So intent address lets you accomplish an arbitrary action just by sending funds to that address. So if you can imagine, like, let's say I want to put $70 into Polymarket. We can generate an address that represents that intent. And then if I send $70 worth of any coin on any chain to that address, then relayers will be able to come in and permissionlessly do the rest, but only that. So there's no counterparty risk. You're not necessarily trusting anyone. It's just by sending money to this address, you're expressing an intent of like, I want $70 to show up in this other place on this specific chain. And so these are the kinds of things. So sending funds via a transfer, via a permit, and you can accomplish all kinds of things like a deposit. That was the example that I started with. You can do swapping and bridging. You can even do arbitrary contract calls on the receiving side. We did a really nice launch with our friends at Ethereum OS, Freedom Factory. You know, they're making a new kind of hardware wallet. And the pre-sale for that involves like minting a pre-order NFT. And that's an arbitrary contract call, but you can still do it via a single transfer. Yeah, with that, I'm going to hand it back to Andrew, and he's going to walk you through the different steps of like how we can do progressively more with intent addresses.
One way you can think of intent addresses that would make it easier is think of it as sending funds to someone's wallet address, and they execute a contract call on your behalf. Now, this sounds kind of worrying. You're sending tokens to someone that you potentially don't trust, and they can do anything on-chain with your funds. This is what the problem that intent addresses solve. You send tokens to an intent address, and this intent address permissionlessly and trustlessly guarantees that only one action can be executed on-chain. How do we do this? We use create2, like DC mentioned, to do this. For those of you that don't know, create2 is a way of deploying smart contracts. It takes a hash of your contract code and generates a deterministic address that you know beforehand. If you change the code, you change the address that the contract is deployed to. This way, you know beforehand exactly what the contract is going to do when you send the tokens to this address. So we'll use an example here of minting an NFT on using USDC. So I transfer tokens to this create2 address, and then now anyone can come in, deploy the contract to the address, and this contract can only do one thing. It can only mint an NFT with a contract you specify. It mints the NFT by sending tokens to that contract and gives the NFT back to the user. Now, what's the point of doing all this fancy stuff with create2 when you can just use your EOA wallet? The first thing it enables is a single wallet pop-up to execute this contract interaction. The normal flow has always been approve the contract, then execute the contract call. This is something we've become numb to in Ethereum, and a terrible UX for users that we've just accepted as something that we have to deal with. With intent addresses, if you noticed, all you have to do, all the user has to sign is one transfer interaction. No more two pop-ups, just a single pop-up to execute an on-chain call. Another benefit this gives you is it allows people to pay or to interact with contracts on-chain using an exchange. So you can now mint an NFT, interact with any contract on-chain with a Coinbase or a Binance account. You transfer funds to a predetermined create2 address, and that address executes the contract call on your behalf. Now, how does this move us towards a unified Ethereum? One really cool thing intent addresses enable you to do is arbitrary bridging. So you can set an intent address which sends the funds into a bridge, and then on the other side, retrieve the funds out from the bridge. Here's an example of how we can do that. So now let's say I want to mint an NFT on Base, but I only have Ethereum on Optimism. What can I do with intent addresses to do this? I'll first transfer my Ethereum to an intent address. A relayer comes in trustlessly and swaps the Ethereum for me and sends it to a bridge. In the contract, I can guarantee that at least X dollars of USDC must come out of the swap, otherwise the contract reverts and the relayer can't execute that function. So the relayer completes the swap, sends it into a bridge like CCTP, and then later on the destination chain, this is the cool part, I can now trustlessly execute the contract call on the destination chain. How do we do this? When the bridge completes, it transfers USDC to the same intent address on the destination chain. This contract, because Optimism and Base are both EVM chains, I can use the same contract code and have it hashed to the same create2 address on both chains. So the contract on the destination chain will now approve the NFT contract and make a call with USDC. You've just seen how I trustlessly sent funds to an intent address and had my intent completed on a separate chain, completely separate chain, fully trustless, fully permissionless. Anyone can come in to complete this contract call, and your funds will never be stuck because you yourself can complete it. What does this enable for you? Well, I don't need, as a user, I don't need to have gas on the destination chain. If someone was building an app with intent addresses, the relayer holds gas on both chains, and the user only needs to hold gas on the source chain. This is because the relayer completes the contract call for you on the destination chain. What's next from here? Well, CCTP and other bridges often take a few minutes. For example, CCTP can take up to 20 minutes to complete the bridge. How can we do this instantly? I want to do something on another chain and have it instantly complete. Here's how fast finish and claiming works. On the source chain, the flow is the same. I send ETH to a contract, a relayer comes in, swaps it, and initiates a bridge for me. Now, on the destination chain, the relayer will, as soon as they start that source transaction, they have a guarantee that if they trust the bridge, 20 minutes later, the funds will arrive. So what they can do is they can immediately execute the contract call for me. So they call a fast finish function on an escrow contract, and this mints the NFT for the user. What the escrow contract does is it tracks who finished this contract call for the user. And then later when the bridge completes, instead of sending that to the contract or to the user, you send it to the relayer who finished the contract call on behalf of the user. So if you look at the funds of the relayer on the destination chain, they execute the contract call. They're down, let's say, 100 USDC to mint the NFT. And then 20 minutes later, when the bridge arrives, they get paid back for that 100 USDC that they executed on behalf of the user. So 20 minutes later, the bridge completes. The bridge transfers the USDC to the intent address. And then now the relayer can deploy the intent address. And because the relayer address is tracked in the escrow contract, the intent address knows to send the funds to the relayer instead of the user. To summarize what intent addresses does for unifying Ethereum, it builds a better user experience. No more 2 wallet round trips, only a single wallet pop-up. You can pay with your Coinbase account or your Binance, and this enables a larger user base to interact with your app. You sponsor gas on the destination chain, so your user no longer has to hold gas on 2 chains to interact with your contract. Better interoperability. Your user can pay you with any coin on any chain and have trustless and permissionless guarantees that the intended action they wanted to execute gets executed. Funds will never be stuck because the user themselves can complete the action if no relayer comes in and does it for them. How have we used this in the real world now? One of our partners, Small Brain Games, built this app called Tomorrow News. It's a prediction market that lets you bet on tomorrow's New York Times headline. You enter in what you think the New York Times headline is, and the more accurate it is, the more you get paid out. However, they only accept Ethereum. What we did for them is we built a deposit flow that allows users to send any coin on any chain, and it automatically bridges and swaps using the intent address mechanism to deposit funds into the app. Another one of our partners is Freedom Factory. They're building an open source, open hardware wallet that runs on Ethereum. They have a checkout page that only accepts USDC on base. And what we enable them to do is accept any coin on any chain to pay for their wallet. If a user doesn't have ETH or degen on base, they can pay with their coins on Optimism, their coins on Ethereum, their coins on Binance Smart Chain.
Yeah, let's play the demo. I think they've got it.
Here's a quick demo of intent addresses. So
oh, it's got no audio. I'll just narrate it. So this is the like an example of an intent address in action. So we're going to click any crypto. This is actually the DymoPay modal. This is our what we've built around intent addresses. Shows all of the different tokens. We're going to do a single transfer in one token. Oh, over to this side? OK, deal. And almost immediately, you should see this say payment completed. As soon as that shows, the fast finish on the destination chain has already cleared. Roll-up Ethereum is really fast and cheap now. We have 1 cent, 1 second transactions, really beautiful. And so you can see this is already done. And then under the hood, 20 minutes later, the relayer will get paid back via CCTP. That's all we've got there. Sweet. Should we do the bonuses? Mm-hmm. Perfect. We have a few bonus round things. We're going to show some other things we can do with intent addresses beyond all of the stuff we just showed you. So the core of it is like make an experience that kind of feels as nice as like Apple Pay or Google Pay, but it lets you do anything on Ethereum from one transfer. But what if you don't even have gas on the source chain? We talked about not having gas on the destination chain. For assets that support it, like USDC, we can do entirely gasless intents this way by just having the user sign a message that is a permit, for example, a USDC permit message. And then the relayer does everything else. Then another interesting place that we can go with this, so intent addresses have this property that they are ephemeral. So we create an intent address representing one specific action, and then once that action is done, that contract doesn't need to exist anymore. Self-destruct, some of you are probably familiar with the history, but it's been like a problem opcode in the past. It used to have a gas refund associated with it. That was deleted because it caused problems. But at this point, self-destruct only exists atomically within a single transaction. You can create a contract, you can self-destruct it later within that same transaction. So we actually think that there's no more reason to not have the refund. And having the refund would be really nice for use cases like this. It would make intent addresses a bit cheaper, and it would incentivize anyone who's using ephemeral addresses like this to clean up after themselves and not pollute the state tree. And then lastly, once this is more, once this idea has more mileage on it, and we know the common use patterns, right now it's this new thing, it's exciting, but once it's really sort of more Lindy, we could write an ERC that allows a really beautiful progressive UX, where wallets that support it can show the intent. Where I say, I'm sending, what I'm actually proposing is a transfer to an address, but it will show you, yeah, you're actually sending, this much USDC to Vitalik.eth over on, Optimism, this other chain. It can surface that to you. And then for wallets that don't support it, it'll just show as a transfer to a bare address, but it degrades gracefully, it still works. I think that's just about all we've got. Let's go to questions.
Wow, guys, you have 15 questions lined up. Yeah, this is so interesting. So let's start with the first one. What is the incentive for Relayer to deploy the Create2 wallet, since deploy contract is usually expensive?
You want to do that?
So there are two ways you can do this. If you're running an app and want to use intent addresses for your app, you can run your own Relayer to provide a better user experience for your users. Your users won't have to pay gas, and you can do cross-chain actions on their behalf. Another way you can incentivize relayers is to have a tipping mechanism. So the user sends some tokens to the contract, and then you can bake into the contract that the relayer collects like a 3% fee or however much you want to incentivize relayers to pick up these intents and complete them for the user.
Yeah. Another thing I would say is deploying contracts is actually not that expensive on L2, which is this system is definitely built for the roll-up universe. One nice thing there is that these contracts are very small, because we're doing like minimalist proxy contracts that point to like a mutable implementation contract, and they just have constructor arguments that basically encode the parameters of the action of the transfer, the payment, whatever it is. And so the size of contract code that you're deploying for one of these intent addresses is fairly small. I'll answer this next one because it's closely related. Do intent addresses lead to increased chain state bloat? This is why we would like the self-destruct refund back. We actually run our intent addresses currently without chain state bloat with self-destruct at the end. But there's currently no incentive to do that. You don't actually gain anything from it. And so having that also come with like effectively like a gas discount for cleaning up after yourself would be great.
Okay. Next question is, if multiple people transfer tokens to an intent address, how can the contract know who sent what in order to reward them separately?
Totally.
So the intended way an intent address is to be used is you generate like an intent address per user or per interaction. And this way, you know like which user is going to send tokens to the contract. And if other people send it, it could be like funding for the user. So for example, with the NFT example, for each user that wants to mint the NFT in your app, you could generate a new intent address specifying them as the recipient. And then you could also, for example, purchase a gift for your friend and transfer tokens to that intent address. But the intended way it's to be used is once per interaction per user.
Totally. And that said, it does support multiple assets going in. So you can do this very nice thing. Let's say I want to do an action that takes $100. I want to place a polymarket bet. I can send $50 worth of token A and $50 worth of token B to an intent address over here on base, for example. And any relayer can come in, swap those however it needs. The intent address is just going to guarantee that like whatever they do, $100 of USDC have to go into the bridge and then fast finish it on the other side. So you can do multi-payments, but yeah, it's not, they're one per action.
Okay, next question is, do these intent addresses look like accounts on a Solana except for the relayer?
The ticker is ETH. I don't know about that.
Okay. How much gas would it cost to incur the trigger, to start the trigger the action on intent address? Assume it's just ERC20 transfer.
So in our experience, in particular on L2s, it's really cheap to use this intent contract mechanism. So for the gas cost you pay as a relayer is the cost to deploy the contract, and then the cost to execute the function on the contract. So for an ERC20 transfer, that's like much less than a cent, and the cost of deploying the contract is also less than a cent. So in our experience on L2s, it's been less than a cent to use intent addresses.
Totally.
This is connected to the next question, which is, what is the additional cost of deploying contract code for every transaction?
Yeah, actually, I have a two-part answer to this. So currently, we're seeing these intent addresses, these intents going through for on the order of a cent in gas costs. If blobs go more into price discovery and blobs become more expensive, the interesting thing here is all of the other things, compute, contract deployment, all of these things actually stay cheap on L2. The one scarce resource at that point is call data, and there's some really nice things we can do to optimize how much call data we use. So we anticipate this is going to stay cheap.
Okay, that's it. Time's up. Thank you very much.
Thank you, everyone.